error quality at hand with just one fragment, which is in one transaction system of blockchain. So if it goes up there, if you use the DCE with an acknowledgement, it's much better because you can send it out and wait for the response. You don't need to be always online, so to say. And if you sort of do a couple of things, we are quite okay with that. But nevertheless, you need something like 500, 600, 700 joule at hand. On the other hand, we looked into some sort of network server delivered packets, so with respect to the error situation as well as the deliver ratio, and you basically see that the listen before talk, which is the optimization of the underlying communication scheme, is more or less required to ensure that you have a sort of quite stable and low level or close to 100% reliability at hand. So this is just one view on how IoT specific elements for supply chain have to be adapted to make sure that they are reasonably well accessible for such a supply chain. I'm not saying this is a perfect solution yet. There's lots of improvements and rooms out there, but it gives an indication where to go. On the blockchain layer, as I mentioned, we developed a couple of years ago our own blockchain because we wanted to have a blockchain at hand where you know what you're doing. Because once you do it yourself, you know what bloody fingers means. Using Ethereum is fine, but then you cannot really play around with all the different consensus mechanism optimization you want to do. So we developed basically Basel. It started out with a proof of work element, but then moved very quickly into the proof of stake one, US version with sharding as of today. As you see, we have worldwide 20 nodes being deployed on Amazon Web Services up on our local node here in Zurich. It's not a large blockchain in that sense, but it's something which is fully controlled. Just the opposite of a decentralized blockchain, but if you need to run experiments, it's the best that you know what's going to happen. And basically, you start out with 20 transactions per second, already quick, a little bit quicker than obviously the Bitcoin guys, then very quickly moved to 50 transactions per second by adding a sharding, which is basically a community-based approach, and we are now at the moment at 1,000 transactions per second with a miner per shard. So it's quite okay. We like to see something like 10 or maybe 100,000 transactions coming along, but that's still a long way to go. What we currently do is looking at transaction aggregation. I will show a slide on that. And besides that, we have a few improvement steps at the moment being discussed. So the transaction covers different transaction types, where basically we try to move the POS scheme with some stronger security levels, like the proof of work will do, and may have an intra-shard communication with minor synchronization at hand. So that's for the blockchain experts in that group. So trying to find a public blockchain with a high level of security with transaction rates above 10,000 transactions per second roughly. And this aggregation basically means that we have a chance of aggregating and summing up matching funds, especially of those aggregations, so transactions which have been out there on the older part. And then we basically ensure that those transactions are being listed inside a single block. So yes, the optimization with respect to the activities you to do between the device as well as the blockchain itself. So try to sort of minimize the input stream as far as possible. Having said that, I'm already sort of trying to conclude because we was told I have 20 minutes time slot. Lots of things I need to sort of talk to you if you're interested in the rate. We basically listed all those measurable impacts our blockchains and IoT have. And this is just a slide which is impossible to read, but it indicates very clearly that there are so many impacts, all the way very low on the hardware level, going to all the security measurements at hand. And that is probably indicated right here. Just looking at a few of those blockchain functions, ordering, mining with different ones. If you want to do them on the blockchain side, forget about them. Don't even think about that. They're impossible. We measured with it all just nothing. But you can submit transaction and vary transactions from IoT devices. That seems to be very nicely doable. And for supply chain, most likely that is a very feasible way of handling it. Because why should an IoT device be a full node? This makes sense. Because a farmer doesn't care about that. It just collects the data, sends it out, and somebody else who sort of operates the supply chain is interested in that. So what's the following? Any idea? Well, most of you who have looked into the Bitcoin case know that, because that's one of those pay-to-pop key hash formats of a Bitcoin address. Fine, isn't it? Well, we know that. We'll use that. Because we have that very well-defined mathematical function. You basically have a public part of your private-public key pair, SHA that, put a right hand on top of that. So we have a very clearly all-electronic, algorithmically designed value. Secondly, what's that? With another string. Sure. Looks slightly different, doesn't it? Well, that's your private key, which tells that you own, and I was told that's Beverly of Seoul in the Gangnam district on the high top floor. It's a value, a very high value asset. So that's basically an information of the property you may own. And that's a private key. You better know, of course, if you have a public part of that as well, because that public part of the key has to go somewhere on that property. It has to be sort of attached immediately to that apartment. But can you guarantee that? Here's no algorithm, here's no mathematically well-defined function which indicates that an object in the real world has a value which you only can generate by applying that mathematical formula. And this is the key issue. Blockchains typically, up to now, have required and still require e-assets, electronic assets, which you can generate and uniquely define and check by applying mathematical functions. IoT not necessarily can deliver that per se, because you have the problem of taking sensor data out of the world. And if you sense your temperature and I sense the temperature, my temperature is always better than yours, because I like to optimize that. So then Rolf will look at me, you're going to cheat. I said, yes, because it's easy. So you have to have, in the IoT world of data being persisted inside the blockchain, a very, very clear path of how to ensure that data being measured in real life is really data you want to persist. Because it's not the blockchain maintaining the correctness, it's the device doing the measurements maintaining correctness. If you do that for sensors, we follow typically those SA parameters and units, such as temperature, CO2 emission. It seems to be doable, and we have done that in the modern case for temperature. You have a certified sensor at hand with all sort of tamper-proofness around it, because if you start drilling a micrometer hole into it, you can fiddle around with that calibration, and that has to be detected. Otherwise, the blockchain will basically persist being spread out, as I mentioned yesterday. Blockchains and IoT can be technically integrated, especially if we understand how those IoT communication models work, how efficient they work, but they require trade-off decisions. They cannot do everything all at the same time. As I mentioned, I listened before talk, which is one of those channel access models on the sort of lowest level at hand, and you add a specific form of the automated repeat request on top and have something on transaction aggregation. It seems to be doing okay. I'm not saying that's the best way to do it, but that's the first step on why we believe things like that could work. And last but not least, because many people still say, well, blockchains will revolutionize the world, and they're sort of pushing many areas into a very different state. Let me state the following. Blockchains do not show a revolution at all, because we have a very specific computer science abstract data type evolution at hand. Those backward linked lists, which includes the signatures and the cryptographic mechanisms on those links, which we know from C, they harden that approach. We have a combination of abstract data types plus cryptography at hand. That's the sort of outcome why blockchains do work. And they help basically in that sense. On the other side, if you have such a linked list, we do not always need to distribute all the consensus across all the parties in the world. In that blockchain, it may make sense because we have cotton farmers here, we have the collectors of the cotton in some place, we have the fabrics manufacturers in different places, and we have finally brands selling the suits and shirts and whatnot. So in that sense, we have a distribution around the world most likely. But even if you take the Swiss case of the farmers' milks and cheese and yogurt production, the distribution of aspect is not that large. It's possible, but most likely doesn't really help too much. And last but not least, because people talk about revolutions, we all know revolutions only work successfully when they completely wipe out an old system and establish a new one. Tell me please one example where a blockchain-based solution has wiped out anything else which is out there. I haven't seen that yet. So it's a nice evolution, it helps. It has benefits, but it's not revolution. Thank you very much. Thanks for your attention.
Thanks for the speech.